Hello fellow Java developers, welcome back to our making an example of a real-world Apache Camel application series. In this video we will test our route making HTTP requests. Let's begin. A quick reminder of what we did in the last video. We've created this signed document route that creates a JSON request from Java object, sends it to HTTP service, reads a response, parses a response into another Java object, and logs the status into database via this SQL log endpoint, and then sends the message to the next route. And what we want to do now is we want to refactor our test codebase a bit so that the tests for this and the next route are easier to write. And a quick fix of a small blunder made in a previous video. Here we have our SQL URL in which we of course don't need to specify this SQL colon. We just need to provide our SQL query, and same in the signed document route. Now let's go to our existing read document route unit test and see what can we reuse in our new signed document route unit test. Well, it seems that we can reuse most of the logic. We will have same advice with calls, but of course different route ID, different endpoints, etc. And the test logic will be similar. We will create some kind of input body, send it to our route, and then with our mocks endpoint we will verify that the message is processed as intended. Now what we can clearly see is repeating here is this advice with camel context, and then route ID calls. Of course, lambda here is different every time, but this part of code is repeated very often. And it will be repeated even more, because in this route we have not one, but two endpoints inside the route. This means we will need to mock one more endpoint the same way, and this means that it's better for us to come up with something that does not require us to specify this advice with camel context read document route ID every time. So let's go to our tests, create util package here, and in that package we will create advice with util configurable class. This class will have private final camel context, and it will also have private final string route ID. Let's add a constructor, and as in our unit tests we almost always do the same calls. For example, replace from with will be repeated in each test, because in each test we'll need to replace it with test start. Then intercepting and sending to mock will also be the same in each test. We can just code this logic in our advice with util configurable class. Here it is. As you can see, in this replace endpoint method we're passing original endpoint and replacement and doing our regular intercept, send, and to logic. Add endpoint on route completion method will add specified endpoint on completion, and replace from with will of course replace from endpoint of the route. Now instead of specifying this advice with camel context and route ID every time, we can just create new advice with util configurable, pass our camel context and our route ID to it, and now we can replace our static method calls with calls to our util class. Let's do that. Now we've replaced from with. Now we need to replace endpoint. Let's actually call get row URI. So here we're replacing our SQL endpoint with mock SQL. And lastly, we want to add endpoint on route completion. So we're doing exactly that. Now our before each annotated replace endpoints method is much shorter, and it will be even more significant in the next test that we'll write. The next thing that we need to do here to make this test reflect our latest changes is we need to replace endpoint rather than add endpoint on route completion, because our read document route now has the endpoint to which it sends resulting message. This means that instead of appending this endpoint in our test, we need to replace endpoint instead of adding the endpoint on completion. And which endpoint will we replace? Of course, this one to which our route sends the resulting message. And the last change that we need to do in this test is we need to add this exclude routes annotation, because now that we have several camel routes in our Spring application context and consequently in camel context, we want to isolate just one route that we're testing in this unit test. So we add exclude routes, and in this exclude routes annotation we specify all the route classes except for the one that we're testing in this unit test. So in our project right now we have just sign document route and read document route, and this is not a component yet, so we don't specify it. And that's why we're excluding this sign document route, so that it is not added to camel context and does not interfere with our unit test. And let's run our test to ensure that it works normally. And here we have it. Now let's also reflect latest changes in our integration test. Here we also need to add the same exclude routes annotation and specify the route classes that we don't need in this test, because in this integration test we are testing our read document route only. And as we again now have an endpoint at the end of the route to which it sends its resulting message, we don't need this on completion advice with method call, so we can delete it. So instead of adding the endpoint at the end of the route, we just replace it, same as we did in our unit test. Now let's run our test to see that we didn't blunder anything. And as you can see, it works as expected. Now when our tests reflect our latest changes in the existing route, we need to add tests for our newly added route. We will start from adding test of our sign document request mapper bin that just takes an exchange and from its message body and headers and injected values makes a sign document request. I will edit out this part because this will be a very simple unit test, but I will show you the results. And now we have our unit test along with several other test utility classes. First of all, I've added the test itself. It creates camel message along with expected sign document request. Then it sends camel exchange to our sign document request mapper make sign document request method and checks that this method maps all the headers and values specified as expected. Now, the utility classes that I've added are the following. I've added this camel exchange support class that is made for other service test classes to extend, because the logic of creating camel exchange that we then send to our service methods is the same for each our service test class. As you can see, file metadata extractor test also extends this exchange support, because same as in make sign document request method, in extract file metadata method, we're accepting an exchange. So in each of these tests, we need to create exchange, then set headers and body to it. So this logic now is in this base Camel Exchange support class. And the second utility class that I've created is this test constants class. Here we'll be storing different values that we use in our tests so that we don't have to retype them every time. Here I've provided some random UUID as an API key and a default CAD ESC as a sign type. Now let's create a unit test for a route. For that, we will copy existing unit test, we will rename it to sign document route test, and here, of course, we need to exclude another route. Here we will also replace our endpoint names. Now let's add mock endpoint for our HTTP service. Let's call it mock HTTP sign service, and the same name will be in its string representation. Now let's inject the endpoint here, same as others, and here we need to mock sign document request mapper, because that's the bean that our route uses for processing. And in our replace endpoints method, we need to make it so that we're making replacements in our sign document route. And here let's get HTTP endpoint and let's replace it with this mock HTTP sign service endpoint that we also inject in our test class. And as our sign document route sends the resulting message to the send document route start, we will also replace this with mock end route endpoint. So basically what we do in this replace endpoints method is we're replacing all the endpoints that our route uses, this from endpoint, this to, and this to, and the last endpoint with mocks. This way we're testing our route in isolation. Now, as you can see, here we're doing a lot of replacing endpoints. Actually, Camel advice with method allows us to do such thing as mock endpoints and skip that accepts a vararg of endpoint patterns. And this way of mocking endpoints can be seen as more convenient than what we're doing here, because it allows us to mock all the endpoints in a route with one method call. But it has its downsides, because this mock endpoints and skip method actually mocks all the endpoints with mocks that have the same URI pattern as a URI string of the mock endpoint without parameters. Meaning that, for example, our SFTP endpoint will be replaced with mock SFTP, SFTP host, SFTP port / SFTP directory name, and all these parameters will be cut off. Then our HTTP endpoint will be replaced with mock HTTP colon and then this URL, and here we don't have any query parameters. But basically, to get a string for our mock endpoint that we're specifying here in endpoint inject, we would have to get a URI of our initial endpoint with query parameters cut off, which means adding some method that does this extraction of a main part of the URI. And this is why we went with this multiple replace endpoint calls approach. But in your project, if you don't have many endpoints with URI parameters, or if it's more convenient for you to extract a part of URI without query parameters, then you may use this mock endpoints and skip method and avoid multiple replace endpoint calls. Now for our signed document route, we need to check several things. First, we need to check that this bin method is called. Then we need to check that if a valid signed document request arrives at this marshal.json step, then we marshal our Java object to a JSON string. Then, of course, we need to check that this JSON string is sent to this HTTP endpoint and that the response is unmarshaled into an object of the signed document response class. And then we just need to check that the message arrives at these two endpoints. So for that, we will need to create some kind of signed document request ourselves, because our mapper class is mocked in this test. We've just copied the creation of this signed document request object from our mapper test, and now what we need to do is we need to create a JSON string from it. For that, we will auto-wire object mapper, as it is configured automatically by Spring Starter JSON dependency. We can use it to get object writer, and our serialized expected request will be provided by this writer that we've created. And we just add exception to method signature. And now let's just provide a test response object. Here we're just creating it with all args constructor, and in our mock HTTP sign service mock endpoint we can specify that it should return reply body, and this reply body will be a constant in which we again will use our writer to write values as bytes, but now we will use our expected response object. Now to input endpoint of our route we need to send our expected request object, because again we have our signed document request mapper mocked. That's why we're providing this request ourselves. And then we need to verify that our route called everything correctly. So first what we'll do is we'll verify that our make signed document request method was called. Then we will verify that our mock HTTP service received a message, and that message was our expected JSON string. Then for our SQL mock endpoint we only need to check that it received the message, and we're checking the parsing of the response here in this end mock endpoint. Now, as you can see, here we have a lot of assert is satisfied calls. Basically for each of introduced mock endpoints we need to call this assert is satisfied, and what I like to do is to make a separate method. Let's create a class route as utils. This method will receive a number of mock endpoints, and then for each endpoint it will check that its assertion is satisfied. And in our test constants, let's add this test timeout, let it be long, and let's specify that our default test timeout will be 5 seconds, and we will also comment that it is a general constant. So now what we can do instead of calling this assert is satisfied multiple times is we can just call this route test util test assertion is satisfied and pass all our mock endpoints to it. Now let's delete this unnecessary assert is satisfied calls, and let's run our test. And as you can see, the test runs normally, our route behaves as expected. Now let's create an integration test for our new route. First, let's assess which test containers will we need. Well, of course, we will need some local HTTP server to mock this HTTP signed document service, And then we will need a PostgreSQL container to mock our database. So, as you can see, we need the same SQL container as we've created for our read document route. This means that it would be nice to reuse this PostgreSQL container configuration that we already have in our existing integration test. For that, let's create a separate class for our test containers configuration, in which we will store all our existing configurations. For example, instead of specifying PostgreSQL container parameters each time, we will just create public static PostgreSQL container method. Let's call it getConfigured PostgreSQL container, in which we will return the container as we already configured it. And let's also allow passing parameters to that method so that we can specify our user, password, database name, and a list of additional init scripts. Now, to be able to add a list of additional init scripts, we need to add some logic to this method. First of all, we'll make it so that our initial script is always run because it creates our table, and then we add all the rest of additional scripts to this list. So when we have the next script, for example, some second script that will create an entity in our database, we will run it after our init script. For that, let's actually make a variable with our PostgreSQL container, and in current LTS version it does not support adding multiple scripts, but in the last version it does. So if you have a later version than me, you can just use withinitScripts method and pass this list here. But we don't have it, so we will return our result. But before we do that, let's actually run a cycle. So for each script in our initScripts list, we will copy corresponding file to container. So we will take our script file, and as a target we will specify this docker entry point initdb.d directory, because that's where this Postgres 17.2 Alpine Docker image looks for init scripts. And now we need to provide a name for our resulting file, and the main point here is that we need to actually number our scripts so that they are executed in order. So we will concatenate each script file name with its order in a list, and this way we will be able to make it sequential. And of course we need to increase our counter. So what's happening here? We go through our scripts which start from, we go through our init scripts list which starts from this init.sql, and then we have a sequence of additional scripts. For each script we copy its file and append its number starting from 0 to its file name. This way, this first init.sql script will be copied to the container with the name 0_init.sql. The next script that comes from this additional init scripts will be copied to the container with the name 1_ and then this script's file name, and etc. This configuration ensures that our additional init scripts are executed in the same order as we specified them, and if, for example, one script, well, our init.sql creates table, and the second script writes to this table, they are always executed in this order and not the vice versa. And now, when we've done that, let's add a method that we will use in case we don't need any additional SQL scripts. As you might guess, it's pretty simple. We will just call our existing method and pass all the parameters to it, And by the way, I need to rename all these parameters. And as an additional scripts list, we'll pass an empty list. And it's even better to make an empty list in this way. Now let's rename our variables so that they are named by a convention. And same here in this method. We don't want our parameter's name to start with capital letter. And now when we have this, we can replace our container configuration with this method call. What we need to pass is this user and password and database name. And let's actually copy all these values and just delete test timeout because we have all of them in our test constants class. Let's add them here, and this will be our general user and password, and this we will mark as our database parameters. Now let's use these test constants to specify our username, password, and other parameters. And the same here in our newly created getConfigured PostgreSQL container method, we will pass our user, password, and database name, which I forgot to make public. Let's quickly fix that. And now we can use it. And this directory should be actually marked as an SFTP server configuration, so that we don't have any misleading comments here. And let's actually make use of our test constant class all the way through our integration test. And of course, same for the timeout. And now let's run our test to be sure that we didn't break anything. And as you can see, our test runs normally. And now, finally, we can create an integration test for our new route. Let's call it sign document route integration test. And right away, we can copy all the same annotations from our read document route integration test. But here, instead of excluding sign document, we will exclude read document route. And let's start working on our test. So first of all, let's open our route. Here we can see that it starts from the direct endpoint, so we will be able to send message to it from our test directly using producer template, so we don't need to add anything for that. This bin we will also have injected, but what we need to mock is this HTTP service. For that we will use mock server library. Let's add its dependencies. For the mock server client we need org.mockserver, and we'll use mock server netty. Let's actually right away specify scope test and put our version here in this project properties. And now we can use it to specify version in our dependency. And the next dependency that we will need is test containers for mock server, because again we'll be using test containers to mock an external system. Let's also specify scope test here. Oh, by the way, I just noticed that I forgot to do this for this PostgreSQL test containers dependency. Now we have it. And now that we have our mock server dependency, we can go to our test class and create static mock server client that we will initialize during dynamic property source annotated method. Here we will also add our mock server container, and right away let's create a configuration for this container in our test containers configuration class. We'll call it getConfigured mock server container, And here we don't need any additional configuration for now. So let's specify image name macserver/macserver, and the version is the same as we specified for our client dependency, which is 5.15.0. And now that we have our configuration, we can use it to get our container. And let's also copy PostgreSQL container configuration, because we will also need to use it. But this time we will need to provide an additional initialization script, because when testing the second route, we expecting our database to have a log entry from the previous route already. You'll see what I mean in a minute. Let's go to our resources and create this addRow.sql file. And here we have our insert statement. So basically what we're doing is we're inserting in our database entry that would have been otherwise inserted by this read document route by this SQL log endpoint. We're doing this insert statement ourselves because in our sign document route integration test we will not have our read document route, as we're testing only one sign document route. So with that we can continue, and AutoWire producer template and consumer template, we will need them to send message to our route and then check that the log appeared in the database. Let's also AutoWire Camel context and object mapper, as we'll need it to work with our JSONs. And the final thing that we need is we need to mock the end of our route, because that's why we can be sure that the resulting message is constructed in a way that we expect. So we're using send document route start, because that's where we're sending our resulting message. And when we have our mock endpoint, we can use endpoint inject annotation to have our mock and route endpoint injected for us. And with that we have all the tools we need. Now let's configure our dynamic property source. Again, same as in previous route test, we needed to set up properties that are resolved at runtime only. And here we need to do two things. First of all, we need to be sure that this mockserver container is started before we do anything with it. Because sometimes, especially on older hardware, it can take a lot of time to start, and we cannot use it until we're sure that it is started. For that, we will make method that ensures that our container is started. Let's call it wait until containers start. Basically, it will just accept any amount of generic containers, and then for each container, it will ensure that this container is started by calling this container.start method. And now, when we have it, we can return to our sign document route test and use this route test utils dot wait until containers start, pass our mockserver container, and now we can get information from that container without worrying that it might not be started yet. So what will we do with the information from the container? Well, first of all, we will need to initialize our mockserver client. We can do it using its constructor and its host and port we will get from mockserver container. And actually here we need to use getServerPort method. Now, after we've done our mockserver client configuration, we actually need to set properties basically in the same way as we did here in our previous test. But this time we will again create a method for that in our route test util class, so that we can reuse the code that sets the properties, and we'll call the method setTest sign document service properties. It will accept dynamic property registry and an endpoint. And here in the method itself, we need to add all the properties that we need to set for our sign document route. Let's go to our route and see what properties do we need. First of all, we will need sign document.url, and it will be resolved by our endpoint, and we need to provide some path to our test service. Let's actually move this value to our test constants class, because we will be reusing it multiple times throughout our test. Here we have it, and now we will use this test constants dot sign document path to resolve a URL. And now let's go to the next properties. So here in our route we don't have any other properties injected, but in our sign document request mapper we have this sign type and API key, and let's copy them. We already have constants for them in our test constants class because we've used them in our unit test, so we'll just reuse the same constants, and we have our properties set. Now let's call this method, and we will pass, of course, our registry, and as an endpoint we will pass whatever our mock server container returns as an endpoint. And now we have our dynamic property sources annotated method finished. Now what we need to do is, in before each annotated method, we need to mock the end of our route. We already have mock endpoint, so all we need to do is create our advice with util configurable, pass our camel context that we've injected and route ID to it, and we can just replace the final endpoint in a route with our mock. And of course it throws an exception, so we need to add it to the signature. And finally, after all this preparation, we can start writing our integration test. So for the test we will need some kind of expected request and its serialized value, so let's just take them from our unit test for now, and we will need serialized expected response for our mock server to return. So we again use our writer and write our response as a string. So basically what we did here is we just created the request that we'll use in our mock server to specify what it should expect, or in other words, to set up mock server expectation. And we constructed a response so that mock server had something to respond with. Now we'll need to reuse the creation of mock server expectation in our future tests. So again, let's go to our route test utils. Let's create public static void method and call it configure regular sign service response. The method will accept mock server client. Then of course we will need an expected request and something to respond with. So with that parameters we can configure our mock server expectations with request method, which will be actually post, and path we will take from our test constants, and body should be our expected request, and let's add a media type that should be application JSON, as we should send JSON to this service, which is specified in our documentation. And what we actually need to do is we need to provide JSON body object as expected body, because if we're passing a string, sometimes the formatting can mess up our expectations. And now we need to configure our response. For it we need to set status code and body, which we already have. And now when we have this method, we can use it in our test class to configure response. Let's pass our mock server client, and let's actually make this expected request a string. So we will just pass it to our method, and same with this expected response. Now we have our mock server expectation set up. So the only thing that remains to do is to send message to our route start. The body of our message will be the contents of our file, as we assume we received them correctly from the previous route, and as our headers we will specify owner ID, document type, and our database log ID will be 1, as we add only one row to our table. And for that we need to use send body and headers method. And now we started our route. It should create signed document request object, marshal it to JSON string, send it to our mock server. Our mock server will answer with the response specified. This response will be unmarshaled to signed document response class, and then the status in the database will be updated. So we need to check all of that in our integration test. Now the only thing that remains to do before we can start checking all those things is we need to actually wait until our route finishes. We will do that with our mock and route endpoint, because sending to that endpoint is the final thing that our route does, and also because we have very convenient assert is satisfied method to which we can provide a timeout, and the method is blocking. This means that we will not start doing other checks before our route finishes its workflow, and if it doesn't finish in this specified 5 seconds, then we will get an exception right away. Now what we can do is we can get database results same as we did in the test of our previous route, and here we're specifying ID equals 1, same as here, because we're inserting only one row in this add row SQL script. And after we got that, we can actually verify that our mock server actually received a post request. And let's take path again from our test constants, and body should be our expected request. Now, after we've checked that the request to our signed document service was made, we can actually assert that the status was written into the database, same as in our previous integration test. Let's just copy this status. Let's actually also specify that our request should be done exactly once. And with that, our test is ready. Let's run it. And as you can see, it runs normally, which means that our route behaves as expected. And with that, here is the end of our video on making an example of a real-world Apache Camel application. In this video, we've created an integration test for our route, and in the next video, we will add HTTPS to it. Thanks for joining. Be sure to like, subscribe, and hit that bell icon. And if you have any comments or questions, leave them down below. I will answer to all of those. See you in the next video. Until then, happy coding!